10C, nice to see you're back after that last lesson. Domain and range is a little different. We're going to practice a little bit more today, but actually we're going to simplify it a bit in terms of how it's written. So remember, from yesterday, domain and range, when you have a graph, whatever that graph looks like, what domain and range does. Domain describes how much of the x-axis gets utilized. Here, we would be going from this all the way up to positive infinity. That would be the domain. The range, what part of the y-axis is being utilized for range? Well, in this case, we would be as high as that, but not including it. And that arrow tells us we're going forever to negative infinity. So that's what domain and range are. It tells us what part of each axis gets used on a graph. So we talked yesterday about set notation. Set notation requires fancy brackets and then x or y such that then we identify with our inequality what x or y values do we want, and normally we finish with x is a member of the reals if it's a continuous graph, meaning a solid line, and we want everything. That's set notation. Well, interval notation is just a different way of identifying domain and range. We still want to identify the parts of the graph being utilized, but we don't have to use the big fancy brackets and everything. What's really important is please understand that you must be familiar with both methods, set and interval notation. So on page 11, we have that chart where yesterday or last lesson we talked number line, set notation. Now we want to talk interval notation. Well, interval notation uses different brackets. We're going to use round brackets or square brackets or combinations of the two. That's what the big difference is. All we're going to do is brackets. Interval notation is kind of like looking at ordered pairs, because inside of each set of brackets you'll have an ordered pair, and the first value will always be the small value for your domain and range. The second value will always be the big value for domain and range. But the key is which brackets go around the ordered pair. What's important is round brackets. Whenever we use round brackets are telling us not to include the value. So we looked yesterday at some examples where maybe we had this graph, but our first point was an open circle. Whatever this value is, let's just say it's -3. I would want to put -3 as my low domain value, but I'd put a round bracket around it because I don't want to include it. But besides not including, round brackets are also used for infinity and negative infinity. Negative infinity and infinity always have round brackets. My sort of reasoning is infinity and negative infinity aren't specific values. So we don't know exactly specifically what they are. So whenever I put an infinity or negative infinity, I would use a round bracket. So on this example, we see that this graph is going forever to the right. So we're starting at -3 and going forever to positive infinity. So my domain would be low -3, high infinity, and they both have round brackets, because it doesn't include -3 and infinity always has a round bracket. This would change a bit if all of a sudden that was dotted? We now have a low value -3, high value infinity, but this time -3 is included. Well, that's what the square brackets are for. Square brackets are if you include the value in your domain and range. So, round brackets, also referred to as open brackets. Square brackets, referred to as closed brackets. Open, don't include. Or positive, negative infinity. Closed brackets, square brackets, is if you're including it. So like I said, back to the example here, -3 this time is included. We would put a square bracket, closed, because we know specifically, but where's our right wall? It's still going to infinity, so we would put a round bracket. So a much quicker way, we're still identifying from where to where on the axes we're using, but a little bit different symbolism. So let's take a look. Page 19. Question 2 on the bottom. Let's get the domain and range using interval notation. So, from yesterday, this first one B, in terms of domain, I still want to identify where's my low value? Where's my left wall for the domain? My graph goes as far to the left as -2. How far to the right does my graph go? Well, the graph ends there at 1. So I know I'm going from -2 to 1. In terms of interval notation, low value -2, high value of 1, they're both dotted, so there's the domain, -2, 1. And as a quick review, if I did interval notation domain, we would want the x value such that -2 to 1, 2 endpoints, that's special case. Low value, less than or equal to x, less than or equal to 1, and x is a member of the reals. Same information, 2 different ways. That's just the 2 ways to do domain. If we take a look at the range, what part of the y-axis? No different than yesterday. Where's the floor? Our graph doesn't go below -4. Where's the ceiling? Our graph doesn't go any higher than 4. So if we're going from -4 to 4, in terms of interval notation, low value -4, high value of 4, and dots mean we're including -4 and 4 in square brackets because we're including. If I wanted to do set notation, fancy brackets, we want the y value such that, again, 2 endpoints, -4, less than or equal to x, less than or equal to 4, and, oh, not x, it should be a y, my bad. Y is a member of the reals. So it's the same idea, it's just using different notation. If we take a look at C, range, domain. Domain is the x-axis. Where does our domain go? How far to the left? Left wall? That arrow tells me we're going forever to -infinity. Arrow there tells me we're going forever to +infinity. So our low value, -infinity, up to our positive value, +infinity. Low value, high value, and in terms of brackets, always open round brackets around infinity. Our range. Well, the range is the same thing. Where's our floor in terms of range? We're going forever to -infinity. Where's our ceiling? We're going up forever to +infinity. So, range is -infinity, +infinity, and again, Infinity always has round brackets. In terms of set notation, we would want X here, domain, such that, well, if it's everything, X is a member of the reals, that's it. Here, range is everything, Y such that, Y is a member of the reals. There you go. So set notation, a little bit more involved. Interval notation, a little quicker, a little less work. Let's take a look at D and E on pages 19, and then we'll flip over to page 20 for E. Stop the video, give it a try, see what you come up with. All right, page 19D, domain. Domain goes x-axis. Where's our left wall? Well, we see, doesn't matter. We've got two parts, but what part of the x-axis is being utilized? We're going all the way to negative infinity because it goes forever. What about to the right? Where's our right wall? Well, we see our right wall stops at 0. So our low value, negative infinity, our high value is 0. Interval notation, big value, small value, big value. Infinity always has a round bracket, and it includes the 0 square bracket. Range. Well, range, erase some of the gobbledygook that I've got up here. Our range, again, floor and ceiling. Where's the floor at? That's going forever down, so our floor is at negative infinity. Our ceiling, I don't care that it's two parts. How high on the y-axis does it go? It goes up to positive infinity. Focus on the axis, not the shape of the graph. So negative infinity, positive infinity, infinities are always in open round brackets. Over here with E, domain, we go as low as -2. We're going up. How far to the right? Well, graph goes forever, so we're going to positive infinity. Low value, high value. What do I need? Includes the -2, so we close the bracket. Infinity is always open. If I were to do set notation, X such that, excuse me, what do we want for our X values? We want to start at -2 and go up forever. So our X's have to be greater than or equal to -2, and it's a member of the reals. Excuse me. Now we need to do the range. Well, range, we're looking at the y-axis. Forget the fact that the graph splits sort of two ways. Think about it. Where's the floor for the y-axis? Our floor, well, this is going down forever. It's negative infinity. Our ceiling, this part is going up forever. So y-axis, we're going up forever. Negative infinity, positive infinity. Always open round brackets for infinities. Or y such that y is everything. Set notation, interval notations. Same information, a different way. Page 19 and 20. Actually, we're on page 20. G and H. Pause the video. Using interval notation, see if you can come up with domain and range. So what we're looking at, domain and range. Here we go. Domain. What part of the x-axis? Our left wall. The graph doesn't go beyond -5. Our right wall. The graph doesn't go beyond +5. So our domain is from -5 to +5. It includes both of those points. So we have closed square brackets. Range. Y-axis. Floor ceiling. Forget it's a circle. What part of the y-axis gets used? Our floor is at -3. Our ceiling, we go up as high as and not beyond 7. Low value, high value, includes both, square closed brackets. H. Goofy. Backwards N. Excuse me. Backwards N. Who cares? Focus on the x-axis and the y-axis. That's what's important to us. Domain, the x-axis. Where's our left wall? Graph doesn't go beyond -3. Right wall. Graph doesn't go beyond +3. So we're going from -3, everything, to +3. Includes them. Square closed brackets. Range. Floor ceiling, y-axis. We don't go below. Oh, there's our low point there. I don't care that it's a backwards N. We go as low as -6. This graph goes as high as here. There's our high point on the graph. Goes as high as 3. -6, 3. It includes both of those. Closed square brackets. Think axes. Here's two that I've just put together. A little bit different because of the open circle. Give these two a try. See what you come up with, and then we'll do it together. All right. First one here. Domain. Where's our left wall? Left wall's at -2. It includes it because it's a dot. So we want to be as low as -2. We want to be as high. Our graph goes to the 1. But it's an open dot at the 1. So we don't want to include the 1. We put a round bracket. Open. -2, 1, square, open. There's interval notation. Set notation, we would want x such that, because there's two endpoints, small endpoint, less than x, less than 1, x is a member of the reals. But now we have to be careful. Do we want to include the -2? Yes. -2 is part of it. We include it. Do we want x to equal 1? We don't. So here we want to include it. Here we don't. Little bit different for domain and range. If we take a look at the range now, the range, ceiling, floor, as low as -4, as high as +4. Do we include the -4? It's dotted, yes. Close bracket. Do we include the +4? We don't. Open circle, so an open bracket. This is how we can do range. Set notation, we want y such that two endpoints, small, less than y, less than big, y is a member of the reals. Do we want to include the -4 in our range? We do. Include it. Do we want to include +4 in the range? Open. We don't. Just leave it as less than. And finally, in domain and range, just doing interval notation. Where's our left wall? How far? That arrow says forever. Going to -infinity on the low end. Where's the right wall for that graph? It happens there at 4. Infinity, always open round bracket. Here, it's an open, so we don't want to include the 4, round bracket. There's your domain. Range, Well, where's this floor at? How low do we go? That arrow tells us negative infinity. How high are we going with the range? Just to this point, which is at negative 1. Negative infinity, negative 1. Infinity always has an open bracket. Doesn't include the 1, negative 1, sorry. Open bracket. Domain and range using interval notation. Same information, presented a little different. Yesterday, you had these questions assigned as well. Today, I'd like you to do it with interval notation. Compare how do set notation, interval notation look different. Domain and range, only way to get good at it is to practice. Have fun.